Hello everyone. So this is a paper of 23rd January, first shift, which is morning shift, and we are going to discuss that one right now. Myself, by the way, Prashant Khatri, and let's have a look at this. Hello everyone. This is the morning shift of 23rd January physics paper, and let's see this question number 26. A light hollow cube of side length 10 centimeter and mass 10 gram is floating in water. It is pushed down and released to execute simple harmonic oscillations. The time period of oscillation is y into pi into 10 to the power minus 2 second, where the value of y is. So, they are asking about this y value, but before that in this question we have to find the time period of this particular oscillation. Okay. Let us have a look at this. So, I am going to draw this picture over here. You see, this is the tub. You can think of some container, large container, okay, and there is a floating some object, okay, a hollow cube or side length this given as in the question. Now you displace it downward by some distance x, okay. So if you displace it downward by some distance x, the extra force that will be created here will be because of this more extra volume that will be displaced, right. What is this volume? Very simple. If the side length of cube is, let us say L, then what is the volume of this portion? It will be L square, the area of the base into that height, which is x. So, what is the extra force that is generated because of that buoyancy, which is right over there, and we know the formula of it, density of the liquid into volume displaced, that is L square x into g. Okay. This is the force. Now, this force will be the net force also on that particular object, and we know the net force as per Newton's second law is mass into acceleration, correct. So, somehow we can see that this force is actually proportional to the x, right, and then in this particular scenario there is going to be SHM, correct, and therefore, here I can say acceleration is rho L square g x by m, and I know as per standard equation of SHM this quantity is omega square, right. So, what is the time period then over here overall? I can easily say the time period is 2 pi root mass by, right, this reciprocal of it 2 pi by omega simply. So, root of that we have already taken. So, this will become rho L square g. Okay. Now, we just have to substitute the values, length is 10 centimeter, mass is 10 gram, and g you know already it is given as 10. So, take that only, rho is 10 to the power 3. So, my time period of this particular SHM is going to be 2 pi root mass 10 gram. So, 10 into 10 to the power minus 3 in kg, okay. Take it in SI units divided by rho is 10 to the power 3 given here, okay, into L square. The length is 10 centimeter, which is point, you can think of it 10 to the power minus 1, okay. So, square of it will become 10 to the power minus 2 into 10. So, what is this number coming out? So, it seems to be a good number. Let us see, 10 to the power 3 cancelled, okay, and then therefore, this is just 10 to the power minus 4, root of it 10 to the power minus 2. So, it is something like 2 pi by 10 to the power minus 2. So, if you compare here with the exact solution which is given here, it seems like it is going to be 10 to the power minus 2, which will come, sorry, in the numerator. Alright, so the time period over here will be 2 pi into 10 to the power minus 2. So, if I compare this solution what is given in the question, what is my y value? It is going to be 2 over here. So, that is option number 3, right. Okay. So, that is about the question number 26. Alright. So, let us see now next question. 27. A gun fires a lead bullet of temperature 300 Kelvin into a wooden block. The bullet, having melting temperature 600 Kelvin, penetrates into the block and melts down. That means somehow there is a heating effect going on, and because of that heat absorption the bullet is melting down. If the total heat required for the process is 625 joule, they have given the total heat absorbed, then the mass of the bullet is in particular grams. You have to tell the mass of the bullet, and the unit should be grams. Latent heat is given and specific heat capacity is given. So, you know already what is the formula to be used. because there will be energy some amount which will be used to increase the temperature up to 600, okay, and then after 600 Kelvin it will not further increase, it will melt. So, there is some amount will be used to increase the temperature and some amount of energy will be used to melt it. Okay. So, what should be the formula? The Q that is going to be absorbed should be something like m S delta T plus mass into latent heat of fusion. Okay. This is the coming from the chapter of calorimetry over there. So, now this Q is given already, it is how much? 625. So, m can be taken out as common, S delta T plus L is 625. So, what is mass? 625 by S delta T. What is S? 125, and delta T is given, right. It is the temperature is going from 300 to 600 Kelvin. So, therefore, delta T is around 300, okay. And next quantity which is going to be how much? Plus this particular L. L is given as 2.5 into 10 to the power 4. So, let us see how much mass is coming, since everything here is in SI unit. So, your answer will be in kg, okay, and do not forget to convert it into grams then. So, here let us see this 125 into 3, we have this one 375, and this is like 25 into 10 to the power 3, right. So, this can be shortened up, this particular number 375, okay, and then we have 00 plus 25 10 to power 3, correct. So, what is this number? 375 plus 250, right. So, it is going to be how much again? It is going to be 625, right. So, this is like 625 by 62500. So, how much is this number? 10 to the power minus 2 kg, and therefore, in grams it is how much? Multiplied by 1000, it will be 10 gram. Okay. So, what is my correct option? It is going to be third again here, that is 10, alright. So, I hope you are getting it. Let us have a look at next question. Consider a moving coil galvanometer. The A is given. Torsional constant in moving coil galvanometer has dimensions this. Increasing, next point B, increasing the current sensitivity may not necessarily increase the voltage sensitivity. Basically, these are discussing about the sensitivity formula for the moving coil galvanometer. So, we should know that formula, right. So, what is the formula for the current sensitivity? It comes out to be NBA divided by K, right. What is K? K is torsional constant here, okay. And what is my B? Magnetic field, okay. What is my N? Number of turns. What is the A? That is the cross section area of the cylinder which is at the as a soft iron core over there, right, or you can think of loop area, because loop is just covering that cylinder. So, area of that loop is going to be the same, okay. Now, on what parameter it is depending, you can easily see here, right. By the way, the first option, if I go with A option, it is talking about torsional constant. Do you know the formula of torsional constant? It is something like this: torque is equal to that torsional constant into theta, correct. Theta has no dimension, right, and torque has the dimension. So, dimension of the torsional constant is nothing but the dimension of the torque, and what is the dimension of the torsional constant then? It is the dimension of torque, which is nothing but how much? M L2 T minus 2. So, the first option is absolutely correct, A is correct. Then the next option, if I check it out, increasing the current sensitivity may not necessarily increase the voltage sensitivity. We have seen the formula of current sensitivity. What is about the voltage sensitivity? Well, voltage sensitivity is something like this. It is the current upon, you know this formula, you have this current sensitivity, voltage sensitivity nothing but current sensitivity divided by the resistance. One more interesting thing is that the resistance depends on the number of turns, okay. So, overall I can say that voltage sensitivity is depending on what parameters then? It is depending on B, okay, area and divided by torsional constant, Okay. So, increasing the current sensitivity may not necessarily increase the voltage. It is true, it is given may not. Is it correct? Let us see. You can take an example. Suppose if n is increased, what happens to current sensitivity? Increases. But what happens to voltage sensitivity? Here voltage sensitivity is not depending on n. So, therefore, voltage sensitivity will remain same, and hence this B option is also correct then, right. So, this A is correct, B is correct. Then C, moving coil galvanometer can be converted into ammeter by introducing a shunt resistance of large value in parallel. I hope everybody knows that it is a common conceptual question, that we put shunt resistance to be very small value, so that most of the current can bypass it, right. So, the shunt resistance is very small, shunt resistance is very small here. Okay. So, what happens then? This option will not be in going into the correct category. Okay. Next one, look at the D, sorry, look at the C, this was the D. Okay. Look at the C1, if we increase the number of turns to its double, then voltage sensitivity doubles. So, C is related to B only, right. If I talk about the C option, if I increase the number of turns, it goes to 2n, voltage sensitivity will not change, it is not depending on number of turns. So, this option is also going to be wrong over here. Okay. Let us see the last one, which is the E. Okay. Current sensitivity of moving coil galvanometer depends inversely on number of turns of coil. It is absolutely wrong, you can see it from the formula, right. So, this is also wrong. So, which options are correct? Only A and B is correct, right, and therefore, which option is matching? That is the first one. Okay. So, I hope you got this question right. Let us move to the next one. Consider a circular disc of radius 20 centimeter with center located at the origin. Okay. And then a circular hole of radius 5 centimeter is cut from this disc in such a way that the edge of the hole touches the edge of the disc. The distance of center of mass of residual or remaining disc from the origin will be. Okay. So, you can draw the picture. Let us take a disc shape, and I am going to cut a, let us say mass of the disc is m. Okay. And I am going to cut a particular amount of disc from it, so that the edges are going to match, and you know the radius is given as this small disc radius portion is given as capital R is how much, 20 centimeter, and the small r for that smaller disc is going to be given as 5 centimeter, right, and center of the big disc is somewhere here. Okay. Right. So, now have a look at it, that I need the center of mass distance, okay, for which part? If I remove this small disc out of it, right. So, think of it that it's the material is only this much, which is the material? Only this much. Okay. So, you have to find the center of mass position for this particular disc shaded part, and how much distance it is from the center of the big disc. Okay. So, I will consider it as a combination of two discs. Okay. One will be the going to be the big disc, okay, which will be having center at the origin at the just exactly at the center. Okay. Mass is m, you can think of how much mass is kept at this position, m. Okay. And then I will consider one negative mass object disc. Okay. What should be mass of it? For that we can consider that the density of mass distribution is almost same, is uniform. So, using that concept we can find out what is the mass of this in terms of m. Okay. So, let us see, if I talk about the mass of this is, let us say m1, where should I keep this m1 minus m1, where should I keep it? At the center of the small disc, right, and I need to find now what is the value of m1. So, what is the radius first of all? I think you can see it easily. What is capital R? 20 centimeter, small r 5 centimeter, right. So, now you can say that if I talk about the mass, right, how will you write down? M1 by the area of it should be equal to total mass by total area. So, what is my M1 in terms of M? A1 by A into M. Now, area is proportional to the radius square. So, you can say that A1 is going to be small r square, divided by capital R square into m. Now, what is this small r by capital R? 1 by 4, 16, right. So, this will become m by 16. That means, there are 2 point masses and you have to find the center of mass positions, and I can say that it will lie along the line joining the 2 point masses, right, as per the concept. So, therefore, what we will get now? Let us see, you have to use this formula, that what is your position, okay. The formula that you use for this particular RCM, right, and from where you are going to measure it? From this particular origin, okay. So, from this origin you have to match it, how much distance far away is the center of mass of this shaded part. So, RCM will be m1 x1 plus, or m1 r1 plus m2 r2 divided by m1 plus m2, very simple, right. So, what is happening here is that you are keeping minus m over here, and you are keeping, sorry, minus m1 over here, and you are keeping plus m over here, okay. So, what is the coordinate then you will consider for that particular plus m thing? It will be 0, right. So, I will write it down as m into 0, mass is negative, this mass is negative. So, minus m1 into how much distance from the center it is? Well, it is going to be 20 minus 5, which is 15, okay, divided by how much coming? Is going to come divided by total mass is m minus m1. What is this number? Let us see. So, the numerator is just minus m1, which is m by 16, okay, into 15 divided by m minus m by 16. So, 16 m minus 1 is actually 16 minus 1 15. So, this will become how much? It will be minus m 15 by 16 divided by 15 m by 16. So, this is cancelled, and in the end you get how much? This is going to be minus 1 centimeter, or in short you can say that it is at a distance of 1 centimeter. Okay. So, which option is correct? Option number 4 it will be. Alright. So, let us move to the next one. The motion of an airplane is represented by Vt graph as shown. The distance covered by aeroplane in the first 13.5 second is. It is a very simple question. It is a Vt graph, and you know already that how to find the distance over here, right. I hope you remember the formula, how to write down distance. Distance is given as mod V dt integration, and this actually you do not have to consider mod V, because all the time velocity is positive as per the graph, right. So, what you have to do? You just have to find the area under the graph. Integration represents area simply, okay. So, what you will do here? You have to consider this full area, right, up to what time interval? Up to time interval of 30.5 seconds, right. So, somewhere let us say it is here 30.5, you have to consider this full area, alright. So, let us move forward and have a look at it, how can we get this area. It's you can think of it, this shape to be combination of two shapes. One is the trapezium, okay, which you have to find the area of it, and one is the rectangle. You can find it out, separate area for it, okay. And the numbers are already mentioned. This length is how much? 200, okay. This length is how much? It is given as 400, and this length is how much? It is 2. This length is how much now? The total was 30.5, and 30.5 minus 2, it is going to be 28.5, okay. And height is how much? 400, alright. So, let us find out area. So, area of trapezium, okay. So, you can name it as something A, B, C, D, E and F. So, area, whose area I am talking about right now? A, B, E, F, half into sum of parallel sides, which is 200 plus 400 into the height between two parallel sides. What is the distance? 2, okay. So, how much is this? 600, okay, meters, SI unit, alright. Now, what about the area for this rectangle? B, C, D, E, it is going to be how much? Length into breadth, 400 into 28.5, okay. So, you can see here what is 28 into 4, you know it already, it is 112, and there is a 0.5 into 4 is going to give you 2, so 114, right. So therefore overall it is 11400. Okay. Now what is the total area? Now if I calculate, it is going to be 114 plus 6 is going to be 120 100. Okay, that is meter. In kilometer it is how much? 12 kilometer. That is my answer, which is option number 1. So let us see now next question. The electric field of an electromagnetic wave in free space is given by this E vector. Okay, is E vector is having some important terms. Let us see that. How much is the E naught over here? The amplitude, it is 57 into 4 I cap minus 3 j cap. Okay, so this is something like 57. What is the unit vector? If I convert it into unit vector, I have to multiply and divide by 5, because if I have to write down 4 I cap minus 3 j cap, what is the unit vector in that direction? It will be 4 by 5 I cap minus 3 by 5 j cap. So to get this particular format, you have to multiply and divide by 5. So I will do 57 into 5, and then my unit vector will be there, whose magnitude will be how much? 1. So this is my actually going to be the E naught. So how to find B naught over here? B naught will be E naught by C, which is nothing but 57 into 5 divided by 3 into 10 to the power 8. And what is this number now? 3 1 ja, right? 3 1 27 9. So or you can keep it like this format, because in the options the format of the B naught is around this thing only, 57 by 10 to power 8. So no need to go by that. Okay. So just keep it like this, 57 by 3 into 10 to power 8 multiplied by 5, right. So the point now is question about the direction, right. Look at the direction first. Okay, where is the direction of the over here for the electric field vector? What is this parameter means? This is the k vector, right. This will represent what? This is going to represent the k vector direction. Okay, and then this is what? This is the going to be the oscillation direction, 4 I cap minus 3 j cap, right. So you can see that over here what is happening actually, if I recall. Therefore if I draw this pattern, suppose this is x direction and this is the y direction. Where is the k vector? K vector direction is given by that inside bracket part 3x plus 4y, right. This 3x plus 4y from the standard equation can be written as 3 I cap plus 4 j cap into dot with x I cap plus y j cap. So this is my position vector and this is my k vector over here. K vector direction it is going to give you somehow proportional to that particular k vector. Okay, so k cap, which direction is the k cap then? It is the simply 3 by 5 and 4 by 5, right. What is my k cap direction vector? K cap will become 3 by 5 I cap plus 4 by 5 j cap. Okay, so this is the propagation direction. Okay, k cap. Now if you know this propagation direction, you can see it from here, the angle also, correct. What is the angle of this propagation? 3 I cap plus 4 j cap, it is in the first quadrant, right. So where the ray of light is trying to go? It is going in this direction. At what angle from it? 3 I cap plus 4 j cap, that will represent 53 degree. Okay, and but where is the oscillation happening? In which direction? That oscillation is given by the outside bracket part, which is actually 4 I cap minus 3 j cap. That means I cap is positive and j cap is negative. Okay, so which quadrant it is? It is going to be the fourth quadrant. So oscillation of the electric field vector will be like this, correct. So my E vector is somewhere around there, and this is the velocity vector direction, propagation direction. So now you know one rule, right. Where should be my B vector? The direction of B vector should be in such a way that my direction of E cross B should be giving you which direction? It should give you which direction? Direction of velocity vector. Okay. So, where should be my B vector then? So, from this way you will get your particular answer then, right. So, where should it be? It should be, you see they both the vectors are in xy plane, and if I take the cross product of both the vectors, by the way you can also write down that my v vector direction, okay, that v vector direction vector cross if I take with the e vector direction vector, okay, that will also give you which direction vector? It will give you the b vector direction vector. Okay. So, if I do this v cross e, where it is? It is into the board. So, into the board is which direction? It is minus k cap, correct. So, look here now, which option is going to match? Look at the first option. First option 57 by 3 into 10 to power 8, that is the amplitude, correct. And what is our amplitude? 57 into 5 upon 3 into 10 to power 8, not matching. Okay. Look at the B option, second option, minus is coming, fine, because it is going to be the direction, which one? The direction is of minus k cap something. Yes, it can match, let us see. But what about the amplitude? 57, there is a 5, you see the 5 over here at the end, that is something interesting that should match up with my answer, right. 57 into 5, this 57 into 5 divided by 3 into 10 to power 8. So, this is going to be my correct solution or answer of it, the second option, okay, and the rest of them is not going to match up, you can see it clearly. Alright, next let us move to the next question. Okay, so here we have this question says the position of particle is given by this function x as a function of time, the dimension of a, b, c by d. It is a good question, it is a very easy one actually, scoring one, right. So, what is my x? It is a sin t plus b cos square t plus c t square plus d, right. As you know that sine functions, trigonometry functions do not have any dimension formula, right. So, obviously, and you can apply the principle of homogeneity, right. On applying principle of homogeneity, you can say that the dimension formula of x should be the dimension formula of a sin t, should be the dimension formula of b cos square t, should be the dimension formula of c t square, should be the dimension formula of d also. And well, what is the sin t dimension formula? Nothing. Cos square t, nothing, right. So, you can say here this is L, which is the dimension formula of A, which is also the dimension formula of B, and then you have dimension formula of C, and t square will be t to the power 2, which is now equal to finally dimension formula of D. So, well, what is the dimension formula of A? L, dimension formula of B? L, dimension formula of D is also L. So, what is the dimension formula of A, B, C by D? It is going to be L, L, C is L by T square divided by L, right, like this. How much it is? L to T minus 2. So, which option? It is going to be second option over here. I hope it is clear to everyone, right. Let us move to the next one. Regarding self inductance, the self inductance of the coil depends on its geometry. The self inductance does not depend on the permeability of the medium. Before doing this, recall the formula of self inductance. What was the formula? Mu naught n square into volume. What is small n square? It is the number of turns per unit length. So, you will write down mu naught n square by L square, and what is volume? It is area into length. So, my length and length here will cancel, and you will get here mu naught n square area by length. So, here self inductance, is it depending on geometry? Yes, area and length are there. Is the self inductance does not depend on the permeability of medium? No, it does depend, right. So, the first option is actually correct. B option is saying that self inductance does not depend on the permeability of the medium, it is wrong. It is depending on mu naught is there, right. Self induced EMF opposes any change in the current in the circuit, that is absolutely correct, that is like a standard definition, right. Lenz's law, remember, right. What is the reason behind it? Lenz's law. Next option, self inductance is electromagnetic analog of mass in mechanics. Why is so word? Mass, you know, it is related to inertia. It opposes the change in the state of motion, correct. Similarly, here also what is self inductance? Induced EMF, it opposes the change in the current in a circuit. So, there is some similarity, right? They both are like they are opposing the change in a particular physical quantity, right? So, let us see, this is correct. Yes, it is analog of mass in mechanics. Work needs to be done against self induced EMF in establishing the current. Yes, so how much is the work actually? You have already gone through it. The work actually comes out to be your what you do the work on that inductance, it's going to result into half Li squared, that is stored as the energy in the inductor. Okay. So, this option is also absolutely correct, right. So, choose the correct answer from the given option. What is that? Is going to be A, C, D, E only, correct. So, this is the fourth option. I hope it is clear. Let us move to the next question. Given below are two statements. Statement 1, the hot water flows faster than cold water. What is the reason behind it? Very simple, temperature increase. If we increase the temperature, what happens to viscosity? Viscosity is going to reduce, so it will flow faster. That is correct. The soap water has higher surface tension as compared to fresh water. That is wrong, because it has, soap water has surfactant mixed with it, correct. What does surfactant plays a role? It reduces the surface tension. So, the surface tension, right, the let us say sigma is the surface tension, it is going to reduce, not increase, right. So, therefore, statement 2 is false. This is true and this one is false. Okay. So, which option is correct? Statement 1 is true, but statement 2 is false, second option. Let us move to the next one. Alright, here radioactive nucleus N2 has 3 times the decay constant as compared to the decay constant of another radioactive nuclei N1. Okay. What is decay constant? It is that lambda, remember, right. So, when I write down the basic formula, it is written as n equal to n naught e to the power minus lambda t. Okay. So, there is a nucleus which is N2. You can think of N2 number of nucleus at any moment of time as like this. It will be, let us say, initial is n naught, okay, e to the power, but lambda wise I can say the lambda 2 is actually equal to 3 times of the lambda 1 as in the question given. So, it is e to the power minus t. So, it is going to be e to the power minus 3 lambda 1 into t, and for n1 it will be n naught e to the power minus lambda 1 into t. Okay. Now, they are asking if initial number are same, that is what we have already taken here. What is the ratio of number of nuclei of N2 to the number of nuclei N1 after one half life of N1? What is the time, half life time? It is actually ln 2 by lambda 1. This time you have to find out. Okay. At this time, what is the ratio of N2 by N1? So, let us talk about N2 by N1 is going to be e to the power minus 3 lambda 1, okay, plus lambda 1 into t. And what is the t? T is over here how much? It is going to be ln 2 by lambda 1. So, the formula will become e to the power minus 2 into ln 2. Okay. That means, you can write it down as e to the power, right, and ln of how much? 2 to the power minus 2 is 1 by 4. Okay. So, overall it is nothing but 1 by 4. So, which option is correct over here? It is going to be the third option. Okay. So, let us move forward to the next question, right. Okay. So, have a look at it. Refer to the circuit diagram given in the figure. Which of the following observations are correct? Total resistance of circuit. Okay. We will do it one by one. As you see, diode is going to be forward biased here. Why? Because see, this side, this A is connected to the negative terminal of the battery, but the D point is more closer to this positive terminal of battery. So, this will be at higher potential, this will be at is going to be tends as lower potential side. So, it is going to be the forward bias, and there will be forward bias current over here, right. So, now you can think of this circuit to be converted into simpler one like this, okay. And here you go, this is the battery, this is 6-volt battery, right. So, if I assume this is to be, let us say 0, this will be 6, correct. How much is resistance total? 4 ohm, 4 ohm, and this also 4 ohm. So, total resistance of this portion is how much? 4 and 4 together with parallel will give you 2 ohm, okay, and then this 2 ohm and 4 ohm will be in series. So, total resistance in the loop will be how much? 2 plus 4, that is 6 ohm. So, that is correct. A option is correct, right. This A part is correct. Next one, have a look at it. Current in ammeter, current will be what? Current will be total EMF 6 by total resistance 6, that is 1 ampere. So, this is also correct. Next one, what is that? Let us see. Potential across AB, right. So, where is the AB point, by the way? This is my A point and this is my B point, right. If you see here carefully, okay, the current that is coming into it is how much? 1 ampere. Now, this resistance and this resistance is same. So, this 1 ampere will be divided equally, right. How much will be the current in this particular branch of the particular circuit? कितना होगा? How much it is? 1 by 2, which is 0.5 ampere. Okay. So, 0.5 ampere is passing through 4 ohm. So, what is the voltage difference across that resistors 4 ohm? That is the potential difference between A and B. Okay. How much it is? That delta V for the C part, it is going to be 4 into 0.5, which is 2 volts. So, that option is not matching at all. Let us see the D option. What is the current flowing through the D? In the D option, it is given CD, right. This is C and this is D. How much current is flowing through it? 1 ampere. So, 1 into 4 is total delta V is how much? It is going to be, in that case across CD, it will be 4 into 1, which is 4 volt, and this is absolutely correct, right. So, this is also correct D here. Total resistance of the circuit is 8 ohm, that is wrong. So, what are the correct option? A, B and D. Which option is matching? First option. Alright, I hope it is clear so far. Let us move to the next one. The electric flux, you know the formula of electric flux, everyone, right. You have to recall that for this question. What is the flux formula? It is actually the charge by epsilon naught. You can think of it for the Gaussian surface, right, charge which is enclosed divided by epsilon naught. Because this question is about, you can relate from the concept of the dimension formula or unit wise to relate it to which particular physical quantity it is representing, right. So, q by epsilon naught something, you can take it like here. What are the lambda and sigma? They are the linear and surface charge density respectively. So, what should be the q in that case? In the case of lambda, it will be how much? Lambda into length. And in the case of this areal density, what should be my this q2? It should be sigma into some area. Area you can consider, let us say disk pi r square, right. So, now if I look at the flux formula which they have given, alpha sigma plus beta lambda, correct. So, what should be my here alpha sigma and beta in the beta lambda and alpha in the alpha sigma? Well, you can apply principle of homogeneity, right. The dimension formula of alpha sigma should be the dimension formula of the flux, should be the dimension formula of the beta lambda, okay. And what is the dimension formula of the flux? It is charged by epsilon naught, right, q by something epsilon naught dimension formula. And then beta, beta is having we do not know, we have to find that what is beta representing. But what is lambda? Lambda is again, you can see here, lambda is something charged by length. So, this is going to be beta into charged by length. So, I can say what is the dimension formula of beta from here? It will be length by epsilon naught. Okay. Now, what about alpha similarly, right? From this part we can get the dimension formula of alpha is the dimension formula of flux, which is q by epsilon naught dimension formula divided by sigma. Sigma is how much? Q2 by Q2 by the area. Area will go up pi r square. So, this is what happens here. So, overall I can say this is having dimension formula of pi r square by epsilon naught, right. So, I think now you can get the ratio alpha by beta. What should be the dimension formula of alpha by beta? Well, it will be area upon length, okay, and that is nothing but what is that? Length. So, one of the options are there who is having the dimension formula of length, and you can easily find that one, and that is nothing but displacement. ठीक है, okay. So I hope it's clear. Next question. A subatomic particle of mass is given, is moving with velocity this. Under the matter wave concentration, the particle will behave closely like. Okay. So, well, it is moving under matter wave consideration. I hope you remember de Broglie wavelength concept. So, you have to apply which concept? De Broglie wavelength. Apply de Broglie wavelength concept. Okay. How, what is the formula behind it? Lambda is equal to h upon momentum, right, and h they have already given, mass they have already given, velocity also they have already given. So, what is the h? H is 6.63 into 10 to power minus 34, and what is the mass? Mass is 10 to power minus 30, velocity is 2.21 into 10 to the power 6. Can you guess the order of the lambda over here? Let us see, because from the order of the lambda you can easily find that which which of the option is going to match with it. Okay. So, 6.63 upon 2.21, that is 3, right, and that overall it will be 30 minus 4, right, 3 into, correct, how much, 10 to the power minus 10 meter, that is how much, that is going to be 0.3 nanometer. This is a range of X-rays, you can see it from the spectrum chart. Okay. This will be the range of X-rays, then hence you will have the solution of the first option over here. Okay. I hope it is clear. Next one, have a look at it. This is really a good question. This involves dipole concepts. Okay. And let us see this question first. Let us read it out. A point particle of charge q is located at P. Where is the P? Do you see the in the diagram? It is here. Okay, so let us have a look at this question. A point particle of charge q is located at P along the axis of an electric dipole 1 at a distance r as shown in figure. So, where it is? This is my dipole 1 and this is the point P. How much distance? R. Okay. And then they are saying that the point P is also on the equatorial plane of the second electric dipole 2 at a distance r. This is my second dipole, and again that distance is also how much? Is going to be r. Okay. Now, the question arises, the dipoles are made of opposite charge q, fine, they are given already by a distance 2a, and for the charge particle at P not to experience any net force. This is an important statement, no net force. And how do you write down the net force? When you write down the net force, it is nothing but the charge into whatever charge you are keeping there. Here let us say capital Q, so you will keep it as capital Q, okay, and into what? Into the net electric field. This is 0. So, therefore, the net electric field has to be 0. We have to start by this. Okay. Let us find out charge electric field due to all the charges kept over there. Okay. Due to dipole 1, due to first dipole. This is the plus q and this is the minus q and this is the point P. So, due to plus q, it will be this direction. How much? Well, I know from center of this dipole what is the distance. This one is r. So, from plus q this will be r minus a, and from the minus q it will be r plus a, right. Okay. So, now what is the field at P? This the left direction field due to plus q. I am writing down for first time for the plus q, k q by r minus a ka whole square, and then from the minus q part it will be right direction, right. How much it will be? Let us say it is going to be formula wise k q by r plus a whole square. So, what is the net field? Net field in the left direction is k q by r minus a ka whole square minus k q by r plus a ka whole square. This is the field due to dipole 1 at P point, and the direction is overall in the left direction. Okay. Now, let us calculate for the dipole 2 due to 2. If due to 2, if I take, this is a point P, this is plus q and this is going to be minus q, right, and from the center of this is a distance r. This one is how much? This is a. So, plus q will create the field in this direction. How much? Well, it will be k q by r square plus a square, and this minus q will create the field towards the minus q, right, in this direction. How much? k q by again same r square plus a square. So, there are two vectors now, right. Okay. If you see it here carefully, let us say this angle is theta and this angle is also theta. So, I can say now carefully that this is the two vectors equal in magnitude. So, their resultant will be along the angle bisector, which is the horizontal direction only towards the right side, right, and this angle is theta. How much should be the net? Well, it will be 2 times k q by r square plus a square multiplied by cos theta, because each one of them will contribute cos theta component, right. Now, what is cos theta? Okay, look at this triangle. What is cos theta? It is going to be a by hypotenuse, right. So, you can also put it over there. How much it is? 2 k q a by hypotenuse. Hypotenuse is r square plus a square raised to the power half. So, therefore, overall this term will be how much? R square plus a square to the power 3 by 2. Now, this is the field due to dipole 2 in which direction? In the right direction, right. So, this left and right direction field should be balanced, then only we can get the situation, right. So, let us see now. So, k q by r minus a ka whole square minus k q by r plus a ka whole square should be equal to 2 k q a by r square plus a square raised to the power 3 by 2. K q is simply getting cancelled, no need of it, right. And if you further simplify left hand side, you can take the LCM, right. You will get here r minus a ka whole square into r plus a ka whole square, and numerator will be then simply how much? R plus a ka whole square minus r minus a ka whole square. So, 2 ar total 4 ar, right. This is going to be 2a by r square plus a square raised to the power 3 by 2. So, 2a and 2a from here will cancel, right. So, overall this is going to give you some relation, right. So, now what to do? You have to find a by r. So, let us further simplify, let us see how much further it can get simplified. Okay. Now, here you can simplify it like this, it is 2r a plus b, a minus b in the denominator, right, which will become r square minus a square raised to the power again 2 only, right, and there it is going to be how much? It is going to be 1 upon r square plus a square raised to the power 3 by 2. You can further square it, okay, you can further square it, right. So, this is the relation we are getting. Now, we will actually take this relation to the next page, right. So, this is how much? 2 r by r square minus a square ka whole square is equal to 1 by r square plus a square raised to the power 3 by 2. So, 2 r by r square minus a square raised to the power 2 is equal to 1 by r square plus a square raised to the power 3 by 2. Let us do one thing, square on both the sides. So, 4 r square by r square minus a square raised to the power 4 is equal to 1 upon r square plus a square raised to the power 3. Let us cross multiply, this will become 4 r square plus a square power 3 is r square minus a square power 4. Take r square to be common out, 4 r to the power 8, this will be 1 plus a square by r square, and there over r square r to the power 8 again 1 minus a square by r square power 4. Okay. This r power 8 can be cancelled. So, it is something like this, 1 plus a square by r square into 4 is equal to 1 minus a square by r square raised to the power 4. All right. So, this is where we are heading towards, right. I think we have missed this q. So, put that one also over here. So, this is the thing we are getting. Now, the thing is that to solve this mathematically, this particular equation is really a tough task. You might need some software like MATLAB you can use, or Mathematica, okay, to solve exact solution. But then how can this question come in IIT mains then if we are not able to solve it? This question is something is actually challenging your smartness. What you can do, you can think of the options, right, and it is all about choosing the best possible option also, right. So, if I take the options one by one over here, right, What are the options? One is A by R is approximately 10, A by R is approximately 20, A by R is approximately 0.5, or A by R is 3, like these are the options, right. So, if I choose one by one now, we can easily identify which one of them is matching, right. If A by R is 10, suppose, then this number, if you see left hand side, will be how much for the first option? 10 ka square, A by R is 10, right, A by R is 10, 10 ka square 100, 100 plus 1 is approximately 100. So, the left hand side is something 4 into 10 to the power 6, and the right hand side is how much? It is something 1 minus 10, 100 is 99, minus 99. So, power of that is approximately 10 to the power 8. So, these numbers are not matching. So, that option is vanished, right. Look at the second option. A by R is around 20. So, 20 ka square 400, 400 plus 1 is nothing, right. So, 20 ka square is 400, 400 to the power 3 is going to be how much? 4 4 is 16, 16 4 is 64, and then again 64 into 4 over here, right, that is 256. So, 256, right, into this was 400, 10 to the power 6, and the right hand side is how much? It is like 1 minus something 400, that is approximately 400 power 4, it will be again how much? 4 is 16, 16 4 is 64, 256, but with it the 10 to the power will be 8, again they are not matching. Okay, so we will not go with this option. Third option, A by R is half. Half if you do, then 1 plus 1 by 4 is how much? It is like 5 by 4, right. So, 4 times 5 into 5 divided by 4 into 4 left hand side, and the right hand side is going to be 5 by 4, right. Sorry, again it is going to be how much? A by R you have taken half, A by R ka square is how much? It is going to be 1 by 4. 1 minus 1 by 4 is 3 by 4, right. So, therefore, it will be 3 into 3 into 3 into 3 divided by 4 times, right. Similarly, look at the last option. I think this is also not matching up, right. This is something going more than 1 and this is less than 1, right. So, here if you see now carefully what is happening with the fourth option. If I take A by R to be around 3, what is left side? Left side is 4 times 1 plus 3 ka square, that is 9, that is 10, 10 ki power 3, and on the right hand side it is like 1 minus 3 ka square, that is 9, that is 8 to the power 4. Now, 8 to the power 4 is 4096 and this is 4000, they are pretty much closer. So, I will go with the option, it is going to be fourth option. Okay. This is how you can see, but there is now something it is not matching up with the diagram part, which I told you in the beginning, right, that I will come to this point. Here my this option is telling me that my A is greater than R then, but is it so as per the diagram? No. So, there is something ambiguity over here or some maybe problem with the diagram, or maybe they should not have given this diagram like that. So, that everyone will get confused that what is happening here, A by R is coming greater than 1, but as per the diagram A by R is less than 1, right. So, somewhere this could be questionable to the NTA about this question. Okay. So, I think this might be over there objectionable if you have some proper reason. Proper reason could be like this, that A is greater than R coming, but in the diagram it is not giving, right. Otherwise, to be on a safer side, choose the best possible, and that is A by R is approximately 3. Okay. Let us move to the next one. In this question, it is saying a spherical surface of radius of curvature R separates air from glass. Let us draw the picture. You have something like this whose radius of curvature is R. This side is glass on the right side and left side is air. Okay. So, what is the refractive index of the glass? It is 1.5 and for air it is 1. The center of curvature is in the glass median, fine, I can see it clearly, right. And the point object O placed in air on the optic axis of the surface. Okay. So, that its real image is formed at I inside glass. You have to keep a point object O here. Let us say this is at a distance of x. Where is the image? In the glass. Now the thing is the line OI, right? What is O? Point object position, and what is I? The image position. The line OI intersects the spherical surface. Yes, it is intersecting. The next one is at P. This point is P. It's saying that PO is equal to PI. So therefore, this distance will also be x. So what do you have to do? You have to apply the formula. Which formula? Which you have studied in the refraction from the spherical surface, right? I hope you remember mu 2 by V minus mu 1 by U is mu 2 minus mu 1 by R. Very simple. Okay. So, this is my one medium, this is my two medium, the refractive medium is the second one and the incident medium is the first one. So, what is mu 2? 1.5. What is the image distance from that P? It is plus x, right. Here my u is minus x and v is plus x. I will put these numbers minus mu 1 1 upon minus x should be equal to mu 2 minus mu 1, that is 1 by 2 times r, right. This is the concept now. So, let us see what is the value of x coming out to be. So, here 1.5 plus 1 is 2.5, right. 2.5 by x is 1 by 2 r, and from here I can say x is nothing but 5 r. That is the answer, right. Which option matching? First option. Let us move to the next one. Okay. So, this is again another question which is related to capacitor. Identify the valid statement relevant to the given circuit at the instant when the key is closed. There will be no current through resistor R. As soon as if you close the switch, capacitor behaves like a straight wire. Okay, it is talking about at t equal to 0 moment, where capacitor will behave like a straight wire. This is the circuit then. This is 5 volt, this is R. Will there be current? Yes, there will be current. So, this option is wrong. There will be maximum current? Yes, because voltage is going to be shared by capacitance, then later on then the current is going to reduce, right. By the RC circuit, I hope you remember, right. What is the current function here? Current is something I naught e to the power, right, minus t by tau. So, I is going to decrease with time. So, maximum is at t equal to 0. So, the B option is absolutely correct. Potential difference between the capacitor plates A and B is minimum. Well, how do you write down potential difference first of all? Okay? That is something very easy formula. Delta V across capacitor is the charge on capacitor divided by capacitance. Initially at t equal to 0, there is no charge. So, what is delta V? It is 0. So, it is minimum, yes, because slowly and slowly charge will build up on it, right. So, this option is also correct. Charge on the capacitor plates is minimum, that is also correct, right. Choose the correct answer, is going to be B, C, D only. Okay. I hope it is clear. Let us move to the next one. A solid sphere of mass m and radius r is allowed to roll without slipping from the highest point of an inclined plane of length L, right. If you take a inclined plane and a particular object is rolling, right, it will roll down and will reach the bottom. While reaching the bottom, it might have some speed, okay, that is V, clear. Now, they are saying the angle is varied. Initial the angle is how much given here? 30 degree, okay, and the next one angle is 45 degree, but the distance is same. This distance, which one? This one is L, that remains same. Okay, initial theta is 30 degree, theta 1, and then theta 2 is 45 degree. In the case of theta 1, you get the speed as V1. In the case of theta 2, you get the speed as V2. In the end, they are asking the ratio of V1 square by V2 square. Well, you know V square is somehow proportional to the like kinetic energy, and you know the formula of kinetic energy direct, right. What is that? It is half m V square in the pure rolling case along the inclined plane, remember 1 plus k square by r square, right, where k is the radius of gyration. Okay. So, here what do you get in the end? For it is a solid sphere. So, for solid sphere, what is my k square by r square? It is 2 by 5. So, overall I can say this is 7 by 10 mv square. And from where this kinetic energy will come? Work done by, who is doing work here? It is a pure rolling, no slipping. So, work done by friction is 0. and work done by gravity will be simply mgh. How much is this height? This height is L sin theta, correct. So, this should be mg L sin theta. I can easily identify now over here that my v square is proportional to sin theta, and therefore, v1 by v2 ka whole square is nothing but sin theta 1 by sin theta 2 whole square. No square, okay, sorry, sin theta 1 by sin theta 2. So, what is sin theta 1? Sin 30 half. What is sin 45? Sin 45 is going to be how much? 1 by root 2. So, overall how much it is? 1 by root 2. So, that is my answer. Which option is matching? It is third option. I hope it is clear. Let us move to the next one. Alright, so this is a match the column list 1 and list 2. Okay. Pressure varies inversely with volume of an ideal gas. So, it is something like pressure is proportional to 1 by V, or pressure into volume is constant, and therefore, it implies which one? Temperature is constant. PV equal to nRT. So, T is constant, isothermal. Alright. Next one, heat absorbed goes partly to increase internal energy and partly to do work. That means, delta Q goes into internal energy change plus some work. There is some internal energy change as well as some work. If you look in the list 2, first is adiabatic process. Adiabatic process, heat energy change is 0. So, this will not match. Isochoric process, work is 0. So, this will not match. Isothermal, delta U is 0, it will not match. For isobaric, yes, it will match. Okay. So, this is going to tell you that pressure remains constant can be the case for it, isobaric, right. C option, heat is neither absorbed nor released, it is a straightforward adiabatic. In adiabatic you find this situation, right. And then for D option, no work is done, no work in when the volume is not changing, isochoric, and hence which option is matching then. So, for A it is isothermal, that means for A you have to match with the third one, right, and for B you have to match with the isobaric, which is the fourth one, right, and for C you have to match with adiabatic, which is first one, and for D you have to match with the remaining isochoric, which is second one. So, it is like A with 3 and B with 4, C with 1 and D with 2 is going to be third option. Let us move to the next one quickly. Given a thin convex lens and its refractive index is mu 2, kept in a liquid where refractive index is mu 1, my mu 2 is greater than mu 1. So, you can draw the picture, take a thin convex lens, it is kept in a liquid where medium is mu 1 and its refractive index is mu 2. So, radius of curvature here is r 1 and here it is how much? r 2. In second surface it is polished, the second surface has been polished now. So, you can think of something situation like this, surface is polished. So, it will behave like a mirror then, right. Where should an object be placed on the optic axis, okay, so that a real and inverted image is formed at the same place, alright. So, you need to find out where should you should keep it, right, real and inverted is formed at the same place. So, I will discuss this with there can be several methods of it. You can either go by one refraction, then reflection, then refraction again, right, or you can do it by the help of the total power concept also, right. But I will suggest you one thing, it is a very easy method over here, and that method is this, that if you place some object, right, and once it goes for the refraction from the spherical surface over here, it will bend towards the normal, right, because it is going into optically denser medium. When it will bend, then it will hit the mirror. How it should hit the mirror? So that your final image is again here, very simple. When this ray which was going forward hits the mirror, comes back on the same track. And when do you think it will come back on the same track? When for the mirror, where should be the object? It should be at the center of curvature, because if the ray goes like this, it will come back like this, right. So, when it will retrace its path, the image will be again over here, correct. So, what you have to do, the first refraction will take place here, but after refraction where should be the image? It should be at the center of curvature of this concave mirror, right. And they have already given the radius of curvature, this is R1, this is R2. So, for this particular mirror, what is the Fm? It is going to be minus R2 by 2 for mirror, right. So, where should be the position of this image or object? This can be decided very easily now, right. So, what is my u here for the first refraction phenomena at this first surface? Is u is going to be, let us say, minus x, and where should be v after after refraction? It should be at which position? It should be at a distance of radius of curvature, correct, and that distance will become how much? Minus R2, okay, like this. Now, this is u minus x, v is minus R2, okay. Now, can you apply the formula? Yes. What should be mu 2? Mu 2 should be the medium, which one? This one. How much it is? Mu 2, okay. And then my mu 1 is how much? That is mu 1. What about the radius of curvature? You should take the R1 is there, so it is plus R1, okay. Let us use the formula. So, mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 by r. R is R1, okay. Now, let us solve it to find the value of x over here. So, this way we can say mu 1 by x is nothing but mu 2 minus mu 1 by R1 plus mu 2 by R2. Take the LCM, right. So, this will become mu 1 by x R1 R2, right. This will be how much? Mu 2 R2 minus mu 1 R2 plus mu 2 R1, okay, like this, divided by R1 R2. So, how much is x? Mu R1 R2 divided by mu 2 can be taken out common, R2 plus R1 minus mu 1 times of R2. So, which option is matching? Is it the A option, mu R1 R2 by mu 2 times of R1 plus R2 minus mu 1 R1? No. Is it a B? No. It is a third option. Well, root is there? No. What about the fourth option? Yes, I think it is matching, right. Therefore, which option is correct? Fourth option is absolutely correct, okay. I hope it is clear, right. Remember, this concept is used here, you can solve it very fast, that after first refraction, the ray should be bent in such a way that it hits the mirror normally. How it hits the mirror? Normally. And when it will hit the mirror normally, then obviously it will retrace its path, and you can apply principle of reversibility then in the case of refraction once again. So, therefore, you will end up at the same position as the image position, okay. Next question, it is a formula based question. So, there is not much to be discussed about it, right. What is the lateral shift formula? This is pretty much given in your most of the books. This is nothing but h, right, t sine I minus r by cos r. So, very straightforward, fourth option, alright. Next question, you have been given this force. This is a question, this is something I will go into the bonus, okay, because here the problem is the force that they have given is vectorially x square y I cap plus y square j cap. It acts on a particle in a plane. Where is the particle? It is in a plane whose plane equation is x plus y equal to 10. Now, work done by this force during the displacement from 0, 0 to 4, 2 is asked, right. But the problem is that 0, 0 does not lie on this plane, and 4, 2 is also not lying on this plane. Then this question is straightforward, out of some structure is not correct, maybe some numbers might be different in actual question. that is why this question will be raised as an objection. Okay. So, this is question is objectionable, that we do not have the particle in a plane x plus y equal to 10. So, the force work, if you want to find, you will write down like similar formula F dot ds, right, integrate your, it will be f x x square y dx, right, integrate, plus the y component is y square dy, right. You know the coordinates, but it will not match because you do not know whether, if it is following this particular rule that x and y should be related like this, then how come the 0 comma 0 and 4 comma 2 is over there, which is not in the x y plane, right. So, that is why this is not going to match over here. Okay. So, let us move forward to the next question. A positive ion and negative ion has charges this and this, which is 6.67 into 10 to the minus 19 coulomb and 9.6 into 10 to the minus 10 coulomb, and masses are given. Okay. At an instant the ions are separated by distance r. At that instant the ratio of magnitude of electrostatic force to gravitational force is this. Find the value of P. Alright. So, very simple question. What is the electrostatic force? K q1 q2 by r square, right, and the gravitational force G m1 m2 by r square. Now, r square cancel. So, what is your answer should be coming up? K is how much given? K is the given? Yes, 9 into 10 to the power 9. How much is q1? 6.67 into 10 to the power minus 19. How much is q2? 9.6 into 10 to the power minus 10. Okay. Then divided by G m1 m2, G is 6.67 into 10 to the power minus 11, mass m1 19.2 into 10 to the power minus 7, 27, and then it is 9 into 10 to the power minus 27. Okay. Let us find out this ratio, how much is coming? 6.67 cancelled, then we have 9.6 and 9.6, which is actually 9.6 into 2 is how much? 19.2 only. So, that will get you as 2. Okay. 9 and 9 cancel. So, how much is the number wise? It is 1 by 2, and 10 to the power is how much? 10 to the power 9 in numerator, 10 to the power minus 19 and 10 to the power minus 10. Overall it will be 10 to the power minus 20, divided by then 10 to the power minus 11 in denominator, 10 to the power minus 27, 10 to the power minus 27, that is 54. 54 and 11 together will give me how much? It is going to give you 65. So, 10 to the power minus 65, right. So, now the question arises, right, is it matching with some sort of numbers given here? Let us see. So, now if you put these numbers in more simplified, it is 0.5 into 10 to the power 45, it is something like 5 into 10 to the power 44. So, is it matching? Well, I do not think it is going to match, right. So, I think this should also be getting objection over here. The ratio of magnitude electrostatic force to gravitational force should be actually large, right. It should not be something 10 to the power minus 13 over here, alright. So, therefore, this question is also not written properly, and obviously, this will go into objection. Okay. Let us move to the next one. An ideal gas initially at 0 degree Celsius is compressed suddenly to 1/4 of its volume. Sudden process, this is very important point. What do you mean by sudden process? See, in sudden process there is a specific type of process, thermodynamic, that will take place, which we call it as adiabatic process. Okay. Suddenly it appears and suddenly there is no time of heat exchange to take place over there. So, delta Q, you can assume that it is almost 0 and adiabatic process is going to take place over there, right. So, now what happens if it is a adiabatic process? You know the relation P V ki power gamma is constant, pressure is proportional to, it is how much? T by V something. So, you can write around T V to the power gamma minus 1 is constant. You can use this relation. Here it is talking about the same thing, that the Initially it has 0 degree Celsius compressed suddenly to 1/4 of its volume. That is, what is my T initial first of all? 273 Kelvin, right? And what is the volume initial? Let us say V naught. Volume final, it becomes 1/4 V naught by 4. Okay. Now they are asking about the final temperature. Simply use this formula, right? T final V final to the power gamma. Gamma is given Cp upon Cv, right? What is that given? 3 by 2. Use this one. So to the power 3 by 2 minus 1 is T initial V initial to the power 3 by 2 minus 1. So T final will be how much? T initial is 273 multiplied by V initial by V final, that is V naught by 4 to the power 3 by 2, okay, minus 1, that is half. 2 will come, right? 273 into 2. How much is that number? It is going to be 273 into 2, which is 546 Kelvin. So temperature is just doubled. Okay. So therefore, what is the change in temperature? 546 minus 273. Again, the number is 273. That's my answer. Okay. So what is the answer for this question? It's going to be 273. Alright, let us have a look at this question number 49. In the given circuit, the sliding contact is pulled outward such that electric current in the circuit changes at the rate of 8 ampere per second. It means that resistance is going to increase, right? If resistance will increase, then current in the loop, what should be the tendency? Current should decrease. So whatever the rate they have given, it is actually the decreasing rate, right? So if I have to write down di by dt, what it should be? It should be minus 8. Okay. Now let us proceed. Have a look at here. You can apply the loop law in this particular loop, which is 1, right. They are saying at an instant the R value is given as 12 ohm, right. So now if you apply the loop law over here in first loop, what you will write down? Plus 12, and you will assume the direction of current like this. Then what you will write down? You will write down as minus L di by dt. Remember, if you have inductor like this, there is a current like this, and if you go in this direction, in the loop law you write it down as minus L di by dt, similar to the resistors also. Okay, you write down in the direction of current, when current is through resistor, you write it down minus IR, same way also you write it down like this. Now whatever be the di by dt, it is negative or positive, will be taken care automatically. Okay. So minus then IR, correct. This will end up the loop, this will be 0. So what happens here? 12 minus 3 into di by dt minus 8 minus I into 12 equal to 0. So this is going to be 24 plus 12, 36. 36 by 12 is my current. Current is going to be 3 ampere. So that's my answer for it. As an integer, it's going to be 3. Alright, let's move to the last question, 50th. Two particles are located at equal distance from origin. The position vectors of those are separated by, as those are represented by a vector given and b vector is given. If both the vectors are at right angle to each other, that means a dot b should be 0, right angle property, correct. What you will see? 2I cap plus 3n j cap plus 2k cap, you take dot with 2I cap minus 2j cap plus 4pk cap, this has to be 0. What will it give? 4 minus 6n plus 8p equal to 0. So you get one relation over here. Another relation will come, they are the equal distance, right. So equal distance means magnitude of A should be magnitude of B, and let us find out magnitude now. So 4 plus 9n square plus 4 should be equal to 4 plus 4 plus 16 p square, and well, this is nothing but 9n square is equal to 16 p square, right. So what is the value of n? It is 3n, which can be written as plus minus 4 p over here. Now if you substitute over here value of p, you will end up with the value of n then. So what is p? P is plus minus 3n by 4. Let us put it there. Now this will become 4 minus 6n plus 8 times of plus minus 3n by 4 equal to 0. If you solve it, 4 minus 6n, this 4 1 ja 4 2, 2 3 ja 6. So, plus minus 6n equal to 0, right. So, well, you can easily see that I will not take the plus 6n, otherwise it will not be satisfying, right. I will take the minus 6n. So, what do you get? It is going to be 12n equal to 4, and therefore, n is 1 by 3. So, what is n to the power minus 1? It is 3. So, what is the answer, correct answer for this question? It is 3. I hope it is clear, right. So, there are some objection questions which should be objected, okay, and well, that is it. This is the paper discussion. Okay, thank you.